Hello guys, hope you all are doing well. So in today's video we are gonna look at Pandas library. It's a really powerful library in Python. It will help us understand the data frame concept as well. Once we move forward, you will realize that without using Pandas data frame, it's almost impossible to move forward in machine learning or in data science if at all you are planning to use Python as your programming language. So before moving forward, let's look at the data which we are going to use in this tutorial. This is the sample dataset which we are going to use for Pandas tutorial. I have taken only 9 days of data just to simplify. If we are going to do on top of this data, it's easy to validate what changes we are doing. Also, this is live data from Yahoo Financials. This is Tesla's stock market data from 24th March to 14th March. Now, since we have understood the data part, let's move forward into the Python coding part. To save time, I've already created the skeleton program which we are going to use further. So first of all, what we are going to do is like importing the library. It's like most usual task in any Python program. If you are starting, you have to first load the library. So import pandas as pd. It's what I'm using here. Instead of pd you can specify any name, but by standard we use pd. In this line what we are trying to do is reading the data frame. So pd.read excel reads the data from my system. This is the data stored in my system. You can specify relative path as well as an absolute path. I have given a relative path here. So what it does, it's like it reads the data stored in my system and transforms it into a data frame, and it saves the data frame in this variable. Again, this is just a variable name. You can name this variable name according to yourself. Just naming it as df, it represents data frame quickly, and it just goes sync with our brain, human brain, to be more precise. Step, we are calling head function on top of our data frame. Head function is a really powerful function. It will give you the top 5 records on top of the data frame you called. So it's like if you have a data frame, any data frame, you just call dot head function on top of it, and it will display top 5 records from that data frame. Similarly thing it's happening here. So I have just called dot head function on top of our data frame. It's displaying top 5 records. Again, there can be a situation where you want more than 10 records to be displayed. You can just pass in the number here, df.head 10, and it will do. So in our case we have only 9 records, so it has displayed all the 8 records, basically 9 records. The index starts from 0, of course. So next step, I'm trying to know all the columns present in a data frame. Right now in our case I have only 4 or 5 columns, but in reality when we are dealing with really complex data, so in that case you will be having more than 20 or 30 columns. So it's really important to know what are all the columns we are having in that data frame. So to know the column, you just have to call df.column. Once you run it, it will display all the columns available in your data frame. So our data frame is having date open, high, low, close, and adjusted close. Again, there is one more powerful function, df.info, which will display all the informations for that data frame. For example, once I call df.info on this data frame, it has displayed whether this has non-null columns or not, and what is the data type of this particular column. For example, date column has a data type of date time. Open, high, low, close has data type of float 64. Again, if we want to go into more detail of data frame quickly, it's like knowing the inside of data frame. You can just call describe function on top of the same data frame. Once you run it, this is how it will be. So basically it has given maximum, minimum, standard, mean, deviation, everything of that numerical columns we are having. So df.describe is a very powerful function. If you have all numerical columns, just call df.describe on top of that data frame, and it will display all the minimum, maximum, and median of that particular, all particular rows of that data frame, like it's been displayed here. So just let's take one column as an example. Let's take low. So in low, there are total number of columns are 9, and the mean of all the records are 154. A standard deviation is 3.2. Minimum value inside the low is 149. And again, it's like first quartile, second quartile, and third quartile, 25%, 50%, and 75%. And the maximum value we are having is 157. Now in next case, suppose we are interested in only knowing the mean value of a particular column. So Pandas has actually a by default function dot mean function. You just have to call dot mean on top of that particular column and it will return you the mean of that particular column. Similar thing I'm trying to do here. Suppose I'm interested in knowing the mean of open column here. So what I will do, I will just do df open dot mean and will run it. See 155.5. This is the mean. Again, if I'm interested in mean of any other column, I will do the same thing. I will just do df then high. I'm interested in knowing the mean of high column. So it's like df dot high dot mean 157.9. So if you want to calculate it, you can calculate using your calculator and re-verify it. That's why I have taken really less number of records so that we can verify whatever result we are getting, it's up to the mark or not. Now we have taken the mean of high column. Again, suppose we have create a column with name as new column, and that data column should contain the all the records in open, whatever the data is in open multiplied by 2. So this is how it will be. I just run it. Again, if I'm calling df.head on top of it, this is how it will be. It has created a column called new column, which is nothing but in my open, if I multiply it by 2, this is the result how it will be. It's like that. Similarly, we can apply any type of mathematical calculation on top of it. Instead of 2, if I want to do it as 5, this is how it will be. See, right now I have multiplied 5, so new column contains whatever the data numerical column is here, it's multiplied by 5 and this is the result. So let's keep it as 2 only. It's more easy to visualize whatever we have multiplied by 2. Now suppose you have again in the same data frame, if you want your values to be sorted in a particular way, ascending or descending, there is already sort values function available. So on a particular column, you just call that function. It's like df.sort, df open dot sort, and it has sorted your values accordingly. If you see 151, 151, 152. So in my open, where is my open? Yeah, here it is. 158, 158. Earlier it was really in random order. Now we have sorted it using dot sort function. So right now I have sorted only open. Likewise, you can sort high, low, close, whatever column you want to sort, and you want to store result. If any other variable, you can declare that variable as like that sorted underscore values. This is how it is. Now I just have to print sorted values. There it is. Actually, if you want to really know what is the index of that particular sorted values, this is how it will be. So 158, this is in earlier database, not database, in earlier data frame, it was present at index 0. This was present at index 2 and this was present at index 1. But now since we have sorted, this is how it is. So there can be a situation where you want to display only a particular records from your whole data frame. So this is how you can achieve it. So in df, I'm just passing from where to where I want to display. In data frame df, I want to display record from 1 till 4. So what it will do, it will display me 3 records. It will go 1, 2, 3. It will not display 4. So it's like 1, 2, 3 and it will stop while going to 4. So again, if I want to display till 5, I will do like that. 6. If I want to display 6 records, I will do like this 1 to 6. So it will go 1, 2, 3, 4 and it will stop at the 5th. If I want to print all the records from a particular index, this is how I will do. It's like from 1, display whatever it's in there. If you don't supply anything, by default it will take display all of it from index 1. So this is what it will do. From index starting 1, it will display whatever the records it has in. Again, if you want to display a particular slice of record from whole data frame, for example, in our case, if you want to display from 3 till 5th, this is how you just have to supply the index here right away and it will do it for you. It's like 3, 4. One thing very important to remember is like that the last index which we are supplying here, it's not included in the display. Actually, it will go till there, but it will stop. It won't display that. Start. Again, if you want to apply certain conditions on top of the data frame, or you want to sort the data frames based on certain conditions, this is how you will do it. So in this, what has happened, so all the columns where the open is more than 153, only those columns are getting displayed. Understand it like that. In open column, we have numerical columns more than 153 and less than 153. I want in whole data frame only those records where in open column I have values greater than 153. So if we'll closely look at it, in open column, in whole data frame only those records are been selected in which in open column we have values greater than 153. Again, we can concatenate different types of condition here. For example, in my data frame I want to display the records where open value is greater than 153 and adjusted close value is greater than 158. So it will filter on whole data frame actually. So once I run it, this is how it will be. Only three records pertaining to our filter whatever we have applied. And again, let me call the data frame head. That's how it is. So in total of these 9 columns, only these 3 records which suited our filter function. Now, let's try to create a new column with the name of target variable, and let's fill the default values in that column with value 0. So it's super easy to do it using pandas. You just have to use data frame and the column name which you are going to create on the data frame, and the default value you can supply here. Right now I'm supplying here only value 0. So let's see how it will be. Now I'm calling df.head on top of it. This is how it has created a column named target with default value of 0. So here instead of 0 I could have supplied any value. Suppose I want to supply value 11 as a default value. So this is how it is. This has created a new column with default value as 11 11 11 11. So let's make it as 0 because it's more makes sense to be default value 0 in this case. Now imagine a situation where in my target column, instead of default value as 0000, I want it in a categorical format, low and high, which should be based on the column condition in my new column data. For example, if my data in new column is greater than 310, target should contain value high, and if it is less than 10, it should contain low. So this is how we achieve this problem statement. First of all, we will specify the column name here. So inside data frame, target is the one we are targeting here actually. So inside data frame, and this is the function which we are going to use. So function, it's like normal function in Python. Whatever value you supply to it, it will return you high and low based on the condition. Is nothing but a numerical data. So this is how we do it. On df new column, we will apply the check function. So check function by default will check each and every value inside the new column, and it will return high or low according to the condition we have given here. So let's run it. Now if I call head function on top of it, this is how the result will be. Clearly 317 is higher than 310, so the target contains high. Similarly, 304 is less than 310, so it contains low. Now, the numerical column which we were having, it's been converted into a categorical column. It's not exactly categorical, but this is how we can achieve it. If at all we come up with some use cases like that, we want to fill up certain column data based on the data in other columns. Now, if at all we want this high and low to be in uppercase, it's super easy to do in data frame in pandas. You just have to call str upper using apply function within a combination of the column name. So this is how you do it. Just call it on whatever value inside this target column is been converted into upper. It's been all capitalized basically. Again, if at all we want to drop a particular column from the data frame, it's super easy. You just have to use df.drop. So this is how it works. On data frame df, do a drop of the column name date on the axis 1. Axis 1 is basically our column name. So once I do this, df.drop, it has dropped the date column from here. So in my data set, Now I have only open, high, low, close, adjusted close, new column and target. If whether our column has been dropped or not, we can just use df.head function, the most used function in data frame. Basically, we always call df.head to know what are all the records inside it, or just to quickly see what we are dealing with. So df.head, I want to display only 5 records. Just call it up. You see, there is no date column here. Again, if I want to drop one more column, I will do df.drop the column name, whatever column name I want to drop. Suppose this time I want to drop high, so let's apply high here inside the axis 1. And if I do implace equal to true, it will do the changes on the same data frame. If I want supply implies equal to true, it will create a copy out of it and will just display it. But once I supply implies equal to true, it will do the changes on the same data frame. So okay, what is that? High. Oh, so instead of in, it should be in place. Yeah, spelling mistake. So it has dropped high column. How do we verify it? Again, using the head function. So let's just call head. You see, there is no high column again here. Similarly, if we want to drop a list of columns, let's make all the list of column which we want to drop. List drop. Suppose I want to drop open, low. It's like we are trying to drop multiple columns and new column. This is the list which contains all the column which needs to be dropped. What we will do, the code will remain same. Instead of just supplying a particular value, we will supply this list dot drop here. Now let's verify whether it's been dropped or not. See, it's super easy. It has dropped whatever the columns we have supplied here. Basic of Pandas library, how we use it in sync with data frame. This is really helpful and really necessary if you want to move ahead in the field of data science and AI. I hope you liked this video and learned something out of it. See you in next video, guys.